Hi, welcome to Turkish Engineering. In this lecture, we will continue for projectile motion and solve more problems. So, we have one problem here, which will represent our spatial case, which I said for rule 5. As I said, actually rule 4. If our initial velocity, if we are just starting projectile motion from the ground, when initial height will be just 0, so that means I must have a velocity component in the y, which must be bigger than 0. But in this case, as you see for our problem, I'm above the ground with an initial length, with an initial height. So that means I can have only one directional velocity component, and if I don't have any velocity in y, doesn't matter, that will be just projectile motion. But half of projectile motion, where is the second half? Actually, if that motion started from this point, okay, just half, the other half, I will complete the other half, okay, started from the other half from here, then you throw with an with the initial velocity from here, then it came here. Actually, they will be same. They will be same because when you start from here and come here, you will have only a velocity component in x. So this motion, when you start from here, then come to here, and the other one, which is the half of this case, so they are equal to each other. So I can say that this is a projectile motion because I'm starting with an initial velocity only in the x, but I have an initial height. So it will not slide in the x-axis only. It will go only. It will has a motion in the y-axis also. So let's start by this problem. We have a student here. So stand on an edge of the cliff and throwing a stone horizontally. So the initial velocity in x will be just this one, because actually we cosine theta, and theta is 0. Cosine 0 will be just 0. So I will get the initial velocity in x will be just 18 meters per second. What about the y? Initial velocity in y will be equal to 0 meters per second because it is just horizontally thrown. So it's asking about what are the coordinates of the initial position. So I will start by A. Part A, I must put our coordinates. As you see, it's our origin point, and in the x, actually I didn't move. So x initial will be equal to 0. What about y initial? Actually, I started from an initial height. That means our initial y coordinates must be equal to 50 meters, as you see here. So we completed part A. What about part B? What are the components of the initial velocity? Actually, these are our components for the initial velocity. So I will put them here. So this is the part B. What about part C? Write the equations for the x and y components of the velocity for the stone. So how can I put the equations? How can I put, let me just move. Sometimes it's not working, I don't know why. So I move to the part C. I must put an equation for x velocity. So actually the x velocity will not change by time, so will be just equal to initial velocity in x. It will be always constant. What about the velocity in y? Just as a function of time. How can I put this as a function of time? Because it's asking equation for the velocities of the stone with time. Okay, so I must put here time. Actually here the x component is not changing by time, so it will just a constant value. What about the velocity in y? Actually it will be just initial velocity in y minus gt, and I know actually plus ayt. So acceleration in y equals to 9.8. When you just take 9.8, but it is a minus sign, so you will get this one. So our equation for the Vy will be just like this. I know initial velocity in y, right? Initial velocity in y, actually it is 0. So I will get that our function of velocity in y, actually the velocity of y as a function of time will give me this. So this is part C. What about part D? Write the equations for the position of the stone. So I must put equations for delta x. Delta x will be just x final minus x initial. So it's asking about which, not delta x, it's asking for the position. So just put your delta x formula. It will be v initial x times time. But actually it is not asking for this one. It's not asking for delta x, it's asking for x final. So because of x initial is 0, and it's asking for x final as a function of time, so you can say that x final will be just equal to delta x. So you can put this one. Delta x formula will be just as a function of time, will be equal to this. And I know initial velocity in x, so it will be just 18 times time. What about y? How can I find y final as a function of time? I will take delta y, which is y final minus y initial, and will be equal to what? Will be equal to v initial y times time plus 1/2 acceleration times time squared. And because of my half of my acceleration will give me minus 4.9 and then t squared. And we know this formula from the previous video. So what about y initial? Y final minus y initial, and I know the y initial. It's actually 50. So that will be equal to v initial in y times time. Actually, this one is equal to 0. So I will get only negative 4.9 times squared. So y final, or you can say y, just y, as a function of time will be initial point just 50 plus or minus, here I have minus 4.9 times squared. So I was actually this function is telling you are starting from this point, then you are actually going down. Your y per each time, let's put t equals to 1. So you will see that you displaced 4.9 meters down. This is part D. What about part E? How long, how long after being released does the stone strike the beach below the cliff? So it's asking t when it just hits the ground. So how can I know t? It's part E, right? Part E or D? Part E. Let's put part E. How can I know time from what I know? I will get, how can I get the time? So when I hit the ground, I have some knowns. Delta y must be equal to minus 50. Why? Because I displaced below, right? From initial point here 50, and here I have 0. My final point here, my final position will be just 0. Initial point is 50. So final minus initial will give me minus 50. So I have delta y, which is minus 50. So this minus 50 must be equal to what? I know delta y formula, which is v initial. Actually, I put here. I put my delta y formula. Actually, delta y will be equal to just this one, right? Minus 4.9 times t squared, because initial velocity in y equals to 0. So let me take the eraser. So now I will put delta y formula, which is just minus 4.9 t squared. How can I solve for t? Actually, just put its value, just minus 50. Minus, actually, when you multiply both sides by minus 1, you will get this one. So divide both sides by 4.9. So you will get t squared will be equal to this one, right? What about t? When you take square root of both sides, you will get t squared of square root of t squared. You will get t, actually that means t, will be equal to square root of 50 divided by 4.9. So let's see what's our time. 50 divided by 4.9 will give me our time, which is 3.2 seconds. So with what speed actually does the storm strike the beach below the cliff? How long after? So actually I know the time, and in the final part it's asking for the speed and the angle. So it's asking for this angle, which is theta, and the speed, which is the magnitude of this one. How can I know them? So let's take part F. I must know what is our final x. Actually it will be initial x, so it is just 18 meter per second. What about v final y? Actually v initial y minus 9.8 times time, and I know time, it is 3.2, so initial velocity is 0, so minus 9.8 multiplied by 3.2 will give me the final velocity. So minus 9.8 multiplied by 3.2 will give me the last final velocity, which is minus 31.4. Okay, so I know two velocity magnitudes, so I can solve for v, which will be just 18 squared plus this one. When you square it, actually you will get rid of minus sign, so you can put just the positive, because when you take square of a negative value, you will get positive, so you can put just positive. 18 squared plus 31.4 squared in a square root will give me the resultant velocity component, actually the hypotenuse. So it is 36.2. 36.2. Actually this is the speed, because it's just magnitude, so it is our speed when it hits the ground. What about the angle? Angle can be calculated by inverse tangent of Vy divided by Vx, and I know these components, so my y velocity is just minus. I must put minus here, because if our angle is minus or positive, when I hit the ground I'm going up or I'm going down, so this sign will just give me the idea. I will put here 18, I will get the angle. You will see that angle is negative. That means actually your angle is not positive like this, is negative, because you are hitting the ground by this way. I will get a negative angle, that means I'm hitting the ground by this way. If I get positive angle, that means I cannot hit the ground by this way, but actually I must hit the ground by this way, so I must get a negative value. As you see, I will get a negative value. Minus 31.4 divided by 18 will give me the angle, which is minus 60, actually minus 60.2, nearly equals to this value. So that means this angle, which is here, as a magnitude equals to this one, but when you take the sign, actually because you are moving clockwise angle will be treated as minus, and counterclockwise, if you are moving with an angle in the counterclockwise, so that will be a positive angle. This is the idea. I will add just a new part, okay, for just let us calculate the range. How can I calculate the range, which is delta x max here? I will use the v initial x multiplied by time. I know that my initial velocity is 18 and our final time is 3.2, so I can calculate what is the horizontal distance between these 2 points. So I can calculate for the range, which is 57.6 meters. Okay, so actually from this point to that point, our range will be equal to 57.6. Let's solve one more question in this video. So the best leopard in the animal kingdom is the puma, which can jump to a height of 3.7 meters when leaving the ground at an angle of 45 degrees. With what speed must the animal leave the ground to reach that height? Actually, cool question, good question. So I have ground here, and let's say just this puma as a particle starting from this point with an initial velocity, and it's asking about this speed. What's this speed? And I know the angle, which is 45 degrees. So actually it will be just treated as a projectile motion. It will jump, so then hit the ground like as this way. I know that the maximum height will be just 3.7 meters. So how can I calculate the initial speed? I know that delta y max, which will be equal to, from two formulas I can calculate, but I will select this one. V final, actually let's remember, I have V final squared will be equal to V initial squared plus 2 of acceleration and displacement, right? So I can put here y, and here y, and here y, and here y. So my final velocity is 0. Because of this, I will get the delta y. When you send this to another side, you will get that it will be equal to V initial y squared divided by minus 2 times ay. So you can put that will be equal to this one. So this is our formula, because ay will be just negative 9.8. So when you negative 2 multiplied by negative 9.8 will give you this one. This is our formula. So put your formula here, you will get the solution. But actually, this I don't know. I know delta y max, which is this one, but I don't know what is V initial in y. So here I will solve for V initial y. So V initial in y squared will be equal to 3.7 multiplied by this one. And when I take square root of both sides, I will get the solution. 3.7 multiplied by 19.6 will give me the answer. So square root of 3.7 multiplied by 19.6. So our initial velocity in y will be equal to this one. What about the resultant speed? I know this component, which is actually this, just zoom here. So this is our velocity. I must have an initial velocity in x and initial velocity in y. So I know this one. It's not degree, it is meter per second. I know the angle, which is just 45 degrees. How can I solve for v? As you know, vy is equal to v sine of theta, which is this one. So v will be simply equal to vy divided by sine of 45. I know vy, so I will put vy as 8.5. When you divide it by sine of 45, you will get the initial speed. So 8.5 divided by sine of 45 will give you the initial speed, which is 12 meters per second. What about the horizontal range? Can I solve for the horizontal range? I must, actually this is not asking, but I will add this part. How can I solve for the range, maximum range, delta x max? I must know what is T max. T max will be equal to V initial y divided by just 9.8. So I know that initial y, which is 8.5, and divided by this, you will get the time, which is 0.8, we can say 7. It's nearly 7. And what about T total? Will be just 2 times T max. So I will get, just take 2 of this one. So you will get 1.74. Actually, it is nearly equal to this one. So I can solve for the range, which is delta x max, initial velocity in x multiplied by time. And but I don't know here v initial x. I will put v initial x as v times cosine theta, because I know v. So delta x max will be equal to v cosine theta times time. So range, which is delta x max, will be equal to 12, which is our velocity, times cosine 45 degree multiplied by our time, but the total time, which is 1.74, I will get the horizontal range. So 12 multiplied by cosine 45 multiplied by 1.74, I will get 14.76. Actually, this is a huge amount of range. That means that this Puma actually is accelerating in the x-axis and going up with a lot of speed, actually it is just running until it reaches here. So it has a horizontal component of velocity, then starts to jump. So because of initial velocity in x is a huge amount of velocity, so this puma can reach just big amount of range. So this is the question. I will solve 2 more questions, but for the next video. So see you in the next video.